And back again. So I think we got some small minor things to fix up when we go back to our see here, system control ISO world here. First of all, we gotta have I don't think we are initializing the nice mouse input components. They're not even being thrown in here. So we got the name tag components, we got the keyboard input components, but we don't have the mouse components here, so we can just copy this nice fine row right up there. Because we have to fetch them if we even want to be able to use them. So if the scene does not have the mouse components, we don't have the set point components. Okay. And sometimes you're lazy. If I had just done this properly, we could go to find implementation of. If we have just written a simple nice if here, rather here we go with an else here, and say that the parameter component input mouse T is null. Have we just added that thing before? We could have just looked in the log and knew exactly where the problem was, so that's what you get for being lazy in your things here. Cool. Bill. MSG was not found. Well, let's add it and sure, MSG 512. This series has been a very long one. This third part, I thought it was going to be a lot less. Than what it became. Build and run. And nice. See, it was okay. I'm gonna show you what happens here. And need to bring up your do another build and run here. Just gonna get my stuff out of the way here. Build and run. Or rather just run. Here we have the screen, and if I'm going down, it's jumping around, but we are zooming in all the time instead of zooming out. So we gotta fix that. We are jumping around all on the screen as well, but we got mouse input, which is nice. Alright, and we go to the control isometric world, and we're not gonna zoom in, we're gonna zoom out on the down wheel. Rather, when we zoom in, if we zoom down, we zoom out instead. Like so. Build and run. We'll bring this little friend down here, and we are centering on the tile where we are zooming. So we zoom in, we're zooming into that tile at the moment. So it's not the best working code, but it's cool. And we can move around with the arrow keys if we want to. And we should actually add our nice function for moving on the sides of, well, it's kind of nice, or not. We have some kind of, yeah, it's cool. We're gonna get our things running. I thought I had a bug there, but we don't know yet if that's a bug or not. But we're gonna add the scrolling actually to our things. Just gonna look my notes up here real quickly to see where we will do that. And it should be in here, and we can add it to right underneath here. We can say if the ISO engine game mode is equal to game mode overview, I will scroll the map when the mouse is close to the edges. As we go ISO engine, scroll map with mouse. I'm just gonna add the ISO engine here, and it's gonna be better that way. I'm gonna bring this guy down for you so you can have a look at it. Whoops. Now I scrolled very far away because I was accidentally got stuck in my stuff there. I'll bring it down here. And here you can see we are scrolling with the mouse to the edges here. That's nice. We're getting somewhere, people. So we got that functioning now as well. And was it scrolling with the mouse speed? I think we adjusted that. So we can still have a look at the ISO engine just to find scroll. Well, that's not a good thing. I have on this, yeah, scroll, ISO engine scroll map with mouse, and yeah, we got the delta timer in there, so that's all right. That's what I was looking for. Now I want to know why when I'm starting the thing up, it's actually zoomed in a bit. So I'm gonna make sure and know what we are initializing the thing with. Zoom level should be 0.1, but for some reason when I'm starting this thing, it's zooming the things up to. So look here, build and run. That's weird. It's like it's starting with 1.0. So if the thing is, it boots up on the other screen all the time. So but you can show the initial state of it. So as you notice here, it's zoomed in right now a little bit. This is what I wanted to have when it starts. So I got some strange little bugger somewhere that we need to get a hold of. Somehow it's registering that I'm zooming in when even though I'm not doing that. So, or at least I think I'm not doing that. Anyway, we can have a look at that later. For now, we should move onward to tile picking. Yeah, we haven't done that yet. It's it's simple to get some of the functionality back that we had before. Control ISO world, and we can just throw this guy in. Okay, we can add some here. Some comments. User scroll the mouse wheel up. If the user scroll the mouse wheel down. To the map. To the tile under the mouse. Zoom in, zoom out. And zoom out. And here we can add if the left mouse button was just pressed. And we can probably copy the whole row here for starters and change it a bit. This is not going to be mouse wheel zoom. We've got the mouse left click that we mapped. State, component, input mouse. State. What do we have? state, button state released first. And the new, wow, we don't need all that stuff. Just copy here. Alright, and mouse left click state, old state was pressed. This means that you've just released the mouse. You clicked it down and you're releasing it up. There you go, ISO engine. Get mouse type click, like so, and ISO engine. Right. This will record what we are getting at, but we are not drawing them yet, if I remember right. Or are we? Yeah, we have added that texture, that stuff there. So let's see if we are tile picking now again. I'll bring this guy down to you, and we are actually. So if I click the yellow, we are getting yellow, green, up here in the corner. Sweet. So we got tile picking back online as well. Pretty good. And now for the thing that you have all been waiting for. Let's do depth sorting, man. Well, or let's not. Let's throw in the character first. I'm gonna save the best for the finale, or what do you call it? So it's been a good time here, and we're gonna go to part 3 here and go to our texture things. And we're already putting in our character there. That's good. And I gotta remember what to do now. Yeah, we're gonna add a new system now for controlling the character, and this is gonna be a little bit of a hack at the same time, even though it's not. You can perfectly use the system, but I'm gonna do a little cheat for just the character itself. So, but you can remove that later. But this is gonna be system control entity .c. So you can take any entity you want, as long as you can put in trees, dogs, cats, stones, whatever you want in a game. A big house, and you can just say, hey, I want to move the house. And with this system, you will be able to move anything in the game wherever you want in the game, basically. It's kind of powerful. So I'm gonna add that .c file. I'm gonna add the H file as well. In the right folder, please. Control entity.h. Okay. And we're in the H file, which is good. And we're gonna start doing our if and def. System control entity. An entity underscore h. Like so. I'm gonna define that, throw that in, and be glad. In here, we're just gonna add our functions to run the system, and system control entity init void scene. We're gonna have void system control entity void system control entity. Copy that, I guess, and we're gonna set entity to control by entity ID. So the system will only be change the controls for the thing you select to control. So you're not gonna control multiple things at the same time. You just control one thing. And void system and control entity set entity to control by name tag. Scene T, scene name tag. Whoops, not namespace. You want to have a name tag. Doing 32. System control entity get controlled entity. Void system free control entity system. There we go. Let's copy those guys into our C file up here, control entity.c. And we forgot semicolon there, so we gotta fix that up as well in our system file here, entity.h. Otherwise we're gonna have some errors with that later. Back. System control entity. And in here we're gonna need quite a lot of things. So I'm just gonna bring my notes up because there's a lot of things to code. And let's get down to it. Include standard in out, include lib.h, include system.h, include system control isoworld, include the logger, the scene, and I'm going to include the components as well, and we are going to include the ISO engine. Oh yeah, let's define a mask for control isometric system. And we go with define system control entity mask set1. And here it's easy to just find them here first. Keyboard component set name tag and the component set velocity, like so. We could throw in the mouse as well, but it's enough to have a keyboard to move things around, so for now we'll leave it like that. Here we're gonna have some function prototypes. Local functions is what we have here. Void will have map keyboard control. Scene gonna have some int which key, ensure action. Well, not like that, like so. Static void map mouse control. Scene T is gonna be int mouse action. Sure action, like so. Void set keys and mouse controls for the scene T scene. Local global variables. Static int system failed to initialize. We are gonna have scene T scene. I'm gonna have our component. Pointers. Keyboard T, and keyboard input components equals null. It's good, it finds these guys from other files, which is nice. component. Input mouse T. No. Static component name tag T. Equals null. And we're gonna have our static component velocity T. Just copy that thing and just changed it to component position T here. Position components. Oh, we don't need them here actually. We're gonna need the velocity and we're gonna need to render 2D. So I was just thinking wrong there. Render 2D components. Cool. Those are down. You can have a list of the common keys. Static int key move up. Up, down, left, right. The mouse wheel. Left click. So we're just adding a few keys that we want to map every time, and even if the entity doesn't have them, we can just assume these kind of things. And have a look at the thing here in my notes quickly to make sure I didn't do anything stupid. Well, what we're gonna do now is this is the hacky bit I was talking about right now, which should be changed later, but it's gonna be an sint to the signed int 32, and to control static as in 32, and we can say player entity ID. So here's also the other hacky bit that we're going to get things running around. I'm gonna copy a nice value here, which is saying that we assume that the controllable entity IDs will be less than integer, which is the maxed signed in 32 value. So if you get, well, lots of entities, here you have 7,147,000,000, and here you 2,147,000,000 entities. And if you have more entities than that in your game, I'm gonna be surprised. Loaded at the same time doing their things. Well, anyway, that would be cool. So in one way, it's a hacky way to do this, but yeah, because the entity ID is actually going for is an unsigned int. So, well, you can do typecasting and stuff, but I'm just gonna make, for the sake of the tutorial, I'm just gonna do this. Static void. We're gonna have update component pointers, and in here you're gonna say that if the scene is null, we're just gonna return. And here we have to update all these nice pointers. Copy them from the top part there, and here we have to typecast them as well. So equals And here we have ECS scene get component from the scene. That's going to be the component set1 keyboard. So we're just going to copy this and use it for all the other guys as well. And of course update them to be the correct values. Input mouse, name tag, velocity, render to DT. Cool. Mouse, name tag, velocity, and the render to the component. So we're just gonna update those values. The scene is invalid, or it's not valid. And we say update the component pointers. And that's pretty much self-explanationary. So now init functions are on their way. I can say the system failed to initialize is going to be 0. Now since we're initializing things, write to log, and we're going to say initializing entity control system. Well, we can do it flashy with our big capitals there. Now add it to the run log.txt, and we're gonna do if the passed in scene is null, then we will say that we will write to log error in function system control init, and we go entity control system failed to initialize, and we can say the parameter void scene is null, so we know what's going on. And of course we have to write to a run log.txt like so. Cool. I'm gonna flag that the system failed to initialize. Plus 1, I'm gonna return 0. Here we will typecast the void scene to a scene T pointer. Of course, scene like so. Here we get, okay, we can just copy this guy up here. Let's say get the pointer to the keyboard components, and if the keyboard input components is null, if the scene doesn't have the keyboard in components, then we will just log it as an error. Let's copy this guy up here and all of the 3. We can just keep that. I can say scene does not have the component, and we throw this guy in here. And that should be it for that guy. And you're gonna copy all of these actually, because all of these has to be initialized in the system down here. So you're just gonna add them down here and do the same thing here. Just gonna copy this guy here. Seeing that I don't have the components mouse. Exclamation mark perhaps. Oh, it doesn't matter. Just gonna leave it like that. And we can go and say get the mouse input components. Get the name tag, components pointer. And get the render 2D components pointer. Good, and we're gonna add this stuff as well. Goody good, and we have this final thing here. Copy and paste. Render 2D. Here we go. And take a deep breath and be happy. Now what we're going to do now is going to say the player ID, entity ID is equal component name tag. Get entity ID from entity by name. For name tag components, I'm going to look for the player 1 entity, which we have not added yet, but we're going to find him. Num entities. We have to add a guy into write to log. Initializing entity control system is now done. I put that to the run log.txt, right? So, of course, we have to log that the isometric row control system was initialized. All these extra comments are nice. And get the player ID if it exists. So this is what I'm talking about, the hacky bit here, because we're just gonna use this to get our guy running around. So we can tailor this later if you want to make a specific thing, but for now we're just gonna get him on the screen. It's gonna take some time. And go return 1. Turn 1. Right. And I'm gonna have a little break here now and continue read soon. Okay, back. I'm back. So should continue working on our system control entity stuff here, but we need to go in here and copy some guys from here, some of these stuff here, because we want to add both the mouse wheel stuff and the cool things here. This will come here later, but we're just gonna throw them in now. First of all, we're gonna get our int control entity is player, part of the little hack we're doing, but it's just to get things in. We can make those things nice and nifty later on. Need a temp rect here as well, and of course we need to check if the system failed to initialize, or if the selected entity control is equals -1, because if there's no entity to control, there's no pointing running anything in here. So turn out of the function. And of course we have to add our if scene component has been reallocated. If that is 1, we have to update the local global components pointers. If the component pointers has been reallocated in the scene, then we'll do that, okay? And here, yeah, I just noticed a little thing we need to add here, because in here we are actually calling the mouse wheel zoom here, and if that is a -1, we're gonna look at memory that is not correct. So we'll do like this. If that is not equals to -1, and throw it in here as well. And here we will have to add if the mouse click not equals -1, and this and this and this. That's good. Cool. Because we had those guys here and we forgot to add them here earlier on. Okay, back to the code. Then we can just simply say, hey, let's grab all these guys again. And we're gonna throw them in here again. So we delete the stuff there for faster typing. But now it's going to be the selected entity to control here instead of the entity index here for those guys. Then I get the one beneath. That was kind of lame. Can grab that one as well. Let's head on back. Like so. I think that should be completely okay. Zoom the code out a bit. And then we should start by adding the keyboard controls now as well. Mouse controls. And we have keyboard controls here. Key, haven't I mapped these guys? Yes, I have. Key move. Key move up. We can start with that one. If that is not equals to -1, and at the keyboard into components and the selected entity control in there. I'm going to add the actions, and here we have to go and get the key move up. Dot state. I think we should do the I'm gonna start with the diagonal keyboard things instead. So we can take move down here and move right and move up instead. Just gonna do some kind of order of things here. Component input keyboard state pressed. And I'm going to copy that line. I'm going to throw it in here. I'm going to say key move down here. Okay, so if we're pressing, this is the movement stuff we're doing now. The same as you see down here with the player. These things here. We're going to move the player around. And here's where we get the velocity components, and we're going to say that the selected entity to control dot x equals 160 So this is if we set the velocity to move things around. And this should actually be added. Later on we will add another variable here that's going to say that the velocity as well. We should throw it in now, I think. So let's do that. Component velocity.h, we have the x and the y velocity. So we just put them right in there, and we could, I'm just going to leave it for that for now. And continue typing our things here. Wherever we are. Entity here. And now what we need to do, we need to actually set up some rectangles to draw from. And if you remember, he's going to bring the thing up here where it's hiding. I'm going to go to my map, my folder. I'm going to go into the tutorial folder, and we are going to find our stuff. And let's see where you are. Yeah, here we have. Just going to open it up. Open with. So you have our character here. So what we need to do, we need to map these different positions here to the character. So if you remember earlier on, each I can leave it there, I think. Well, I have it in my head, so I'm going to type. I'm going to explain real soon here. So we're going to set up rect. I'm going to set up the temporary rect. 280. So each of these sprites are this is the width and height. The width is 70 pixels and the height is 120. So we are picking the position here. Anyway, this is the right and the down. So we're going right down. That means we're picking this guy here. So that means 70, and you multiply that with, this is the first, this is 0, 70, 140, and so on. So you come here to the 280 here. It's going to be this guy here. So you're just going to map these guys out. Component, render 2D. So clip rect for the render components. For the player entity ID, I'm going to throw in the temp rect here. So that's the first one. This is right down. So we can copy this thing, and we're going to go for the next one. It's going to be right up. Key move down is going to be a key move up. If those are pressed, so I'm going to set that one. And key right up is going to be this guy here. It's going to be 140. 0, 70, 140 there. So this is why I'm talking about this is the hack that we're supposed to do. This guy, and this has to be an else if. So I'm gonna get some water here because it's my throat is a bit. A lot better. All right. Next up, we will do left up, I think. Key move left. Oh yeah, we have to set this to minus 160 as well, so we are moving in that direction. Remember now that this is actually the grid is a diamond now and not a square, so it's a bit different. And this is the left up. Oh yeah, this has to be Y as well. X, Y, and this will be X minus 160. And this guy is actually going to be the first frame here, up left, so it's just going to be 0 here. Left down here, key move down. Key up, move left, move left. That will see whatever we do wrong later. And here, when we're moving, should be Y. 160 on this guy. And this is going to be the second frame, I think. Yeah. 070, is this correct? No, it's going to be 420 around here, I think. Yeah. Because we are moving left down. So this will be this guy up here. So it will be around 420, yes. So it's what it's going to be. 42. Now we can go and set our direction up. Like so, and move up. And the up direction is going to be two of these guys, one X and one Y, and X is going to be minus 160, and this is going to be minus 160 as well. This is going to be frame yeah, 70. 0, 70. Good. Then we can do the down key, and it's going to be, oh, here's an error. Move left, move down, good. And we're going to have move up is there, and move down here. It's going to be in there as well. And move down is going to be the opposite here. And the down frame is around, it's there, so it's 380 then. Oh, sorry, 350. Trying to fix it. 335. Yep, and we can do the next one. Be down. This is going to be direction right. And here's going to be a special case because otherwise it's going to run really quickly. So it's just going to be half of the what we have here. And this guy here has to be 490, yeah. Move right. Sorry, move left is the one where you're doing. Oh, did we move right first? Yeah, move right. It's gonna be this frame. It's 210. And we have direction left finally. Here we go. Left. It's going to be opposite, minus 80 and 80. And it's going to be, and this is the last, yeah, 490. 49. 7 multiplies plus 7 is 49. So you have 0, 1, 2, 3, 4, 5, 6, 7. So it's going to be 49. Cool. And we can go. That should be it, I think. Actually, we forgot one very important thing here now. It is actually now we are saying here, in all of these parts here, we're saying that we will set up the rectangle no matter what entity it is. So we have to put our if thing in here and say like a control entity. If the control entity is player. Yep. And where are we setting that? Nowhere right now, so we have to add that as well here. If deal with this check, we can just say if the entity being control is the player, and we can just say that if selected as control is equal to player entity ID. Flag that the player. So we're gonna put that in here. Alright. So now as we are down here, we can go, and if that is so, if that is 1, then we will do the stuff we have within the brackets, curly brackets. Okay. And copy that line of code, and we're only going to do this if it's the player, because it's very hard coded and hacky, but it's just to get our functionality set up for testing, so we can remove these guys later on. And we should also add the value here, how much it should be decreased with the speed of the velocity. So it should be 2 or more variables in the component velocity system here. So we should have also x speed and y speed, how much we should increase those values with. If we want to. Okay, control entity, and we add this guy in here as well. Like so, like so. There we go, and here as well. Okay, and how many errors do we have? Probably a few. Yeah, expression. Yeah, comma instead of a semicolon. Mouse wheel is undeclared. Mouse wheel soon. The question is if I thought this up here in my notes correctly. Just gonna have a look at this. Well, this is not going to be zoom, of course, because this is taken from the other part. So we only have mouse wheel here. Because in the other code here we had zoom in the ISO world. Because we did have the zooming thing. But here we just added, we just called it mouse wheel. So we're going to change that. Cool. And we're not going to zoom out or do anything here. This is just going to be add functionality here for mouse wheel. So we're not going to keep those. And now we can do build, and ISO engine is undeclared. Well, we're not going to do anything with the left click either. So mouse left click here. And it's not velocity, it should be velocity components is what we are looking for, not develop components. Okay. It's the same thing here. should just copy that and replace this with copy that guy. Replace, yes, 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 yes. Oh, cool, well. Okay, map keyboard control. These guys have not been ready and set up yet. So we have to continue with our next function down here, which is system control entity set entity to control by entity ID. So it's our very long thing here. Then as usual we can start with the see if the scene is null. Log it as an error. Write to log, and we can say error in function. We're gonna say that's parameter scene t scene is null. Alright. And we don't have to do much more than to say return 0 here. Turn out of the function. For starters, and we have to make sure that if the entity ID is larger than the scene enum entities, we're gonna say that we are trying to log something wrong here. Parameter entity ID is larger than the number of component entities in the scene. So, and return 0. If the component pointers has been reallocated in the scene, we will update the components pointers. Component pointers update like so, and we will. And finally, we'll set the entity to control. Select the entity control is going to be the entity ID. I'm going to set the keys. The mouse controls for the scene. And here we haven't implemented these guys yet, but they're coming now real soon. And I gotta make sure control by name tag we should implement that first as well, and then we're gonna add the two final functions for this. We're gonna short MSG 512 U in32i. I'm gonna say copy the scene. If the scene is not valid, scene pointer. You can throw it in here as well, just for if the ID is invalid. And we can throw in the next thing here. If we're gonna take the name tag, I'm gonna see if that is null. Not valid, we will say just copy here, and this is not good. This is a different function name, so we should throw that in here and there. Parameter name tag is null. Like so, and we can go return. If the components have been updated, it should be the same thing here as well. We'll update them, and then we will loop through the name tag components. Entities. If the scene, if the entity with the name tag was found, name tag components, we take the I for that, and the name, and we compare it to the name tag. If it's found, we will set the index for the selected entity to the index equals I. We can set the key mouse controls, which will be implemented real soon down here, and we will say return out of the function. And if not, we should report that, I think. Would be nice. Printf msg. You can do like this. Scene percent s does not have an entity with the name. A name. I couldn't spell properly, like name tag. Present S, and we can get the scene and the name of the scene, and we can get the name tag. Now we can log it as an error. Do like if the entity with the given name tag was not found, we log it as an error. Write to log msg, and we have our run log.txt. I just noticed that we have forgotten to add this stuff on our find things up here, so we should do that as well. Forgot that stuff up here as well. So you might as well correct it before the compiler will scream at us. What about up here? Did we miss it here as well? Well, we'll notice. And we will see how many errors we have. Expected. Yeah. Semicolon there. Yep, undefined reference. Well, it's going to be implemented right now. We're going to get also first fix this function here, where we will say very simply return select the entity control, and that function is completed. And free, we have nothing is allocated in the system, so we leave this one empty. Right? And now we have to implement the mouse map control thing here. These two guys up here. Map keyboard control and map set keys and mouse controls. Just gonna figure out which one we should start with. By ID. Why? Have we got that one? System. What do we have here in our? Am I in the right place? Should we? Am I missing a function? Might be missing something here. Just gonna check my notes quickly here. By entity ID. Okay, not by ID, by entity ID, of course. That's the one I was looking for, so. I forgot that I named it by entity and not by ID, so that's a bit why I wasn't finding my way around the code here, so. Okay. Well, we can throw this one in here. Static void map keyboard control. And it's going to be scene T. Scene. I'm going to get an int key here. Assure action. File 12. I'm going to add an int right error with index. Component input keyboard T and component keyboard input comp. Component input keyboard T. CS get component not easy S scene. Get component of course, and for the scene we're getting another component set one keyboard. All right. Add some checks here, and we can just write it up. I can go here and let's printf msg. We can say error function map key control, and you can say scene present s does not have the component. And here we're gonna add the scene name like so, and we should log this one as well too. Write to log. Run log.txt. I'm gonna do the same thing here with throw them up here first. Do like this instead, and I'm gonna say component name tag T. Name tag comp. And they're gonna be null initially. Copy this guy and we can throw in here. Get that guy there. This is gonna be component name tag tag T. Name tag. Get the keyboard component. Get the name tag component. And now we can finally start getting the key here. Component, keyboard, component input, keyboard, get action, index. Keyboard in component there. Selected and did you can control and the action we're passing in. If the key is -1, we're gonna log key does not exist. Get the action key index. Key does not exist. We will log it as a warning. And question is if we here anyway. We're not gonna return here because we want to write out what's wrong. So if write error with index is that is 0, I'm gonna write this one. I'm gonna add this is not gonna be an error. This is just gonna be some info here. Info from function, and there will be this will be key action %s is not mapped for the entity. %s, and this should be key action. Let's see here. Whoops, that's not what I want to do. Action. Then we will put in name tag component and the selected entity control. Then we will get the name from that guy. Finally, I had to think a bit there to get that thing out of my head, and also we have to put a dot name here, otherwise we won't get it. Okay, and then we gotta do an else. Copy these two lines here. I'm just gonna put entity %d. I'm gonna throw in the entity, which is actually the selected entity control, like so. Good, good. And we can go and close this one, I think. Yeah, good. And we should go on to map the mouse control as well. Static void map mouse control. Scene T. Scene. That's going to be int mouse action. And which action we want to map. Good, good. Component input mouse instead. I just need a name component later, so we can copy some of this stuff up here, and the name component will be the same. So we just need to change the keyboard component here, and we'll be good. And these guys are called from functions that are already checked if the scene is null, so we don't have to do that here. Get the mouse component. Mouse input component, here we go. Just realized I did the I did the wrong thing. Here, there we go. And this will be the component input mouse T. And we get the mouse over here. And a ring function, map mouse control. Like so. Name tag. Oh, see here. Errors do come quickly. There you go. And here we're gonna do pretty much the same. So we're gonna say that the mouse action equals the component input mouse get action index. The mouse input components. Let's select the entity control and the action. And if the mouse action is -1, mouse action index, if the mouse index exists, does not exist. Warning. Copy these guys up here because they're basically identical to this guy here. Info in mouse map control. This will be mouse action. Mouse action. And here we have to change this to action and name tag component. Should be okay, yeah? Because we're passing in the action, so it doesn't matter. They're basically identical. I should go build here and see how many errors we have. Keyboard input component. Ah, yeah. Here you go. Let's declare it up here so I don't see why not. System mouse controls the scene. Oh, yeah, we have to create this guy as well. Somewhere around here. Static void, set keys, and mouse controls. Scene T scene. Here we get the key indexes. Map keyboard control, and we have the scene, and we have key move up. So this is why we have the helper functions that we just wrote to easily get the key indexes. And down, we're gonna have left and right. Now I was gonna get the mouse controls. Map mouse control, scene, mouse wheel, and that's going to be mouse wheel. Map mouse control, scene, and the mouse left click, left button. Okay, how about that? Okay, we have to include our string.h. Like so, and build void. There we go. That should be better. And build. Cool. So we have a nice new system set up that we can use for mapping an entity. You're not gonna remember what we named that guy. Was it player? Yeah, play 1. So we have to add a new entity called play 1. In our tutorial part here. And it should be up in our init function for the moment. Here's isometric control entity, and we have Here's some random guy, but this guy could actually be mapped to. You can say this is our player entity. And it's going to need a few more components, so we can add a few more things down here. We're going to have the component keywords at 1. You're going to have velocity and the position. We're going to add the name tag component as well. Name tag. I'm going to add the component set1 render 2D. Because we want to be able to render him, we want to give him a name, and we want to be able to control him with the keyboard, and the position, the velocity to components to move him around with the move system. Okay. Then we up to the scene, we're going to add here set the name of the entity. I think we might have to. We have our systems as well, so we should actually add the control entity system here. Scene add system to scene. We need the test scene. We're going to put in the system control entity here. So we are running the system for controlling this guy. Nice. Then we can continue here and say that the component name tag set name. And now we need to actually add the name tag component. Well, we have the name tag components right here. So we need the entity that we just passed in here. We are returning the entity number for that guy, so we get the ID for him. And we're gonna name this guy player 1. And we have a position. And I'm gonna do this now, I think, because we can put him. We're gonna add component position set offset position entity 0, and I already know what values to type in here, so it should be 38 to get an offset for his Y position, and we are component position set friction velocity components and entity. I'm going to give this guy 100, so we stop immediately as we move. We have our keyboard controls for this guy, and we need to set we have to add this guy as well here. You see, we have just had a new system, and we have to tell the system that system control entity here we go. Set entity to control by entity ID, and we know his ID because we already gotten this guy out. And here we said set the entity to control to the player entity. Come on, here we go. And we have to set the clip rectangle for the first for the player entity, and we want to set the forward here, so that means it's going to be, let's see here, yeah, it's going to be 350. Cool. Setup rect, and we TMP rect. I don't have a TMP rect, we're going to add one. SDL rect, TMP rect. gonna say 350, 0, 70, and 102. 102 is the height. Let's make sure that we got this right in the input control entity place here. I think we did get it right. Oh, 120 is going to be 102 instead, I think. Gotta check. I'm actually going to have a look at this file and see the exact proportions because I don't remember them right now. Can I have a quick look? And then I will know. It's going to be 102, so that might be... Yeah, we'll see what's going to happen. 102. 102, and it's going to be 102 here as well. I should just have done a search and replace, but there was a few of them, so it's the same speed for that. Good. And it's going to be position components, of course. And this 38 might be off with... This might be minus 18 now as well. I'm not sure, but we'll see. We'll see what we'll get when we'll get there. Alright, and we set up temp rect. And once we have set up the temp rect, we will also have to set the component render 2D. Set texture and clip rect. And we have a render which should be and we have entity. Do we name him renderer? Call him render 2D component, right? Oh, we haven't added him up. Added me up. Cool. Component render 2D. And this has to be the render 2D components. No. This is nice. We almost forgot about this guy. Let's just copy this stuff up here and get this guy down here, and it will be the component render 2D. Thank you. I'm gonna copy this line. Gonna throw me here into our components to the scene. And we have added a component here, but we have forgotten to update and actually set them. We might be setting him down here somewhere. Yeah. Good. We added him and we didn't use him, but now he's in here. Good. Cool. Now we know what to do now, and we gotta go and say render 2D components, and then we gotta go in and get the entity, and let's see your entity, and we need the texture, get texture pool, get texture from texture pool, and we need to have the game, the texture pool, and we're gonna have the character.png, that's what it's called, and we're gonna get set the temp right here. Component render to the set layer. We're gonna put this guy on the 2D component. Gonna get the entity. I'm gonna set him layer 1. Set the texture for the layer, and I was gonna get set the layer to draw the texture on, because layer 0 is going to be the ground for the map, and later on is when we start adding things above. Now I think I have some errors here. There, component render 2D. T, thank you. I'm missing something. Here, parentheses, 2 parentheses, and 1, 2, 1. Render entity. Texture push character and that guy. Why are we having an error? Too few arguments. What am I missing? We need to render to the components. We need a UI entity. We need the texture and the clip right. Should be everything. Well, let's just do it from the beginning then. Sometimes it's easier. First you want the render to the components, then you want the entity, then we want the texture, which is texture pool. Ah, I know what was wrong now. We need to get the pool first. We did that basically. Game.texture pool character.png. And that's done, and we need to add the temporary, the clip right here. No, set up with the temporary. And that should be it. Build. Set friction. Oh, we haven't added that one yet, so we can just temporary outmark that guy and see. System entity control set entity control by entity ID. Fine implementation. And this guy is in our system control here. Entity.c. Yeah, systems, of course. System and control entity.h. Then we go build. And we can't find this the CNT things here, so we have to make ourselves a nice copy of the things we have. Okay. Should these guys even be here? Control entities at entity control. Yeah, we can copy those guys from this guy here. Forward declaration. Throw that guy in here, and then it should be compiling. Good. Cool. I will fix this later because I need to have a quick break now. Okay, these guys have to return something, so we're gonna add it next time. I'll be continuing here. So we have a break now. Okay guys, let's continue here. We have our cool things going on, and it's gonna be here to set up the insert and sort, the binary search, binary search. And I'm gonna get my notes up here. It's another day, so a quick break was turning into next day actually. Okay, here, so we're gonna have a void here, I'm gonna have an end here. So I'm gonna go down to the bottom of things. First we can just try to actually get our guy to render in here. See, I don't think I've wrote that function yet. System render isometric object. Do you have that one? No, I don't have that one. Cool. So we're gonna get this one, system render isometric object, and implement that guy as well. So we can throw him in perhaps just before we render everything here. And here we're gonna need a point 2dt. We're gonna have a pointer to the texture. Texture T. Render 2D components. And we're gonna get the entity and the texture. Point.x is gonna be position components. Gonna be entity dot x multiplied by the ice engine zoom level. So we will draw this guy at the same zoom that everything else is in, and we're gonna have ice engine scroll Y. This should be actually renamed to camera X or something, but it doesn't matter. Oops. That guy really flew away. I'll do the same for Y. Let's scroll Y. And then we're going to do an ice engine convert 2D to ISO. And we're going to get the point in there. And we have converted the point for that now. And then we're going to do point.x plus equals position components entity and x offset multiplied by the ice engine zoom level. So now we're adding the offset for the position. Set the position to draw the object on. Convert it to symmetric coordinates and convert to T. And then we're gonna say just the position with its offset. And now I'm gonna say if the object is within the screen area, point.x plus texture width multiplied by the ice engine zoom level. And not the point.x less than the window width. We can add them on to the same line, and then we're gonna get another one down here for the Y. Can just copy this stuff here. Point.y plus texture height. Point.y is less than the window height. Then we are going to find the position, the tile position. Do we need this? I think so. It's not a tile position, find the this is actually an old stuff we don't need. I think this is gonna need ice engine. Let me think here for a little bit. I'm just gonna draw it now. Nothing else. Texture render XY clip scale is what we want. And we're gonna have the texture and the point X on the point dot y. Let's say the texture clip rect and ISO engine zoom level, like so. So this means that we should be able to draw this guy. So for now, I'm just gonna put him in here. Player entered ID. Build. Okay, position components. What did we name these guys in here? Pos components, okay. Like so, go build. Oh, we need to know which ID we are gonna draw. So how about we make a quick so this will be changed later on because this is just temporary now. Static and player ID. Down here you can just say that the player entered the ID is like ECS. Scene. I don't remember where we are doing this. We need the function. Entity by name, something like that. No, this is what I'm looking for. Component name tag, of course. Component name tag at enter ID by name, blah blah blah. That's good. So we have that guy there. And this will be removed once we have fixed our stuff. If the player entity ID is not equal to -1, then we will draw the guy here. And we don't have the name tag components here, so let's do a quick cheat because this will be removed real quickly here. We're adding the first entity is a system control entity, and the player entity is number 1, so we're just gonna hard code that quickly now. So we can remove that guy, and the same up here. And or do I even have name tag in here? I don't think so. Nope. Well, let's remove that guy. I'm just gonna say draw number 1. Remove the 10 point here because we're not gonna need it for now. Build 1. And I'm gonna show you here that we got a small error. Oops. There. We're drawing him to the wide. See here. So it's something with 120, if I remember right. Yeah, you can see because we're using the move system now, and he has got a velocity set for a direction automatically now. But building 1, he's not moving with the keys either, but we're gonna get this figured out. At least something is drawing, and that it gets a good sign. So we should be able to get. I'll check my log file and see if something's wrong in there. Head into the folder over here. And that's one, and that's that one, and we can go into there, and the logs. So we have a couple of things to do. We haven't added ECS system ID 5, it's not named. And we got some error in the component. Parameter component input mouse input is null. So we gotta get those things running as well. So we can add a system to the scene first. So we're gonna get this one here, find. Oh, in all the files please. Cool. So it's not mapped, so if we don't have it here, control isometric world, that's not control entity. Control entity init, the function we want to have, and update entity be the system control entity update. Free get init. I don't think we are updating anything. This should be null, I think. Because we don't have an update system more than one entity, and we have there. This one should be running, I think. And we should set the free one as well, and this one is system control entity. Entity free control entity system, like so. And if we go build and run now, do we have? Oh, sorry, I forgot to show that to you as well. Gonna run. I'm gonna bring the stuff down here, and if I press right, something happened to the guy. So we get some small errors to look at. Just to these guys. So component input mouse get action index. So whenever we are passing that in, since that is null, so let's go have a look in that. Component input mouse add action. It's kind of weird. You wanna know what we were calling this before this guy happened? SDL log critical. Texture, okay, that's from the other guys. And we're not even getting in there. The game was still running in, we got the same error. I gotta fix this as well. Haven't done that yet. So okay, I'll be taking a quick break here to sort this out. And I'll be back really shortly. Alright guys, time to continue here. And we got some things to fix up. I actually had to do some debugging here before to find out what was wrong, and it seems like the big problem we have right now is actually this init clip thing. So we're just gonna delete this guy because we are our init clip. This thing was actually overriding our settings here, of course, because it's pointing to the same memory as our when we're doing this guy here. That's why we have the big texture in the beginning there. So that is fixed by removing that guy. And we don't care about those guys either. And we can go back to our control entity thing here. And I noticed that here in our map mouse control thing. Okay, perhaps I will fix that. Just gonna make sure. Gonna do some undo here. Yeah, change back directory keys and stuff here. So we gotta go. Yeah, here we are. Cool. Here's where we were just before. Yep, good. And in here we have mouse input components, which should be the mouse input comp that we're getting here. Because when we are calling map mouse control, it's we may not have set up the things up here. You know, all these guys here. So that's why we're gonna do that. And we're gonna go here and paste that in, mouse input comp. And also we had another error, which that we called everything move key up here. Up, down, left. Alright. Okay. Build and run is going to make sure that we are. Here comes our character. And you can see I have not mapped everything correctly here, so we gotta go back to the drawing board for that. So it's jumping around a bit. But it's okay, we can fix that. And we need to do some. Let's see where we should start. Got all the keyboard controls here, and I gotta make sure we find. Get my notes up and going here as well. In the right place. Is here. Okay, move right and move down. X is 1 and 6. That should be okay. And let's say move right and move up. Y is minus that guy. Minus 140. All these have else ifs. That's good. Make sure key move left here. That everything is move up, move right, move left. Minus 160. That should be move up, move left, and move down. X is minus 160 and Y is minus 160. This should be move up. Let's see which one is not doing things correctly here. So if I press down, it's down. Up is that's the wrong one, so we got to change up the up frame. It's not correctly. So key move up. This should be 70, I think, because if we look in our character thing here, wherever I got that guy, here we are. Yeah, 0, 1. So that means it should be position 70. So we start to correct these guys first. Build and run. So down and up, left is okay, right is wrong. So we gotta find the right key now. Up, down, left. So we're gonna fix the right key now first. Key move right. Sorry, move left is the one we are 49. It should be 490. That's why everything is messed up. There's one. Need to make sure we got that right. Left, right, up, down. Up, left. It's not getting both of those correctly. We're gonna fix that. And up and right, down, left, and down. Yeah. So we now have all the directions here, which is good. But they're not moving. It's not moving correctly here when I'm pressing two keys. So we gotta fix that. I gotta figure out what's wrong, dude. Might be that we are we're setting the velocity for X and Y here. And that's okay, it should do that. But why are these guys not working properly? Pressed. That's kind of interesting why this is not working properly. So it could be something in our... Could be in the move system. But usually it shouldn't be that because we're setting everything properly. As far as I know. We're gonna fix the friction as well. We can do that now because we haven't added that here. So we can start by fixing that. See, we'll also, did we add our set friction? Yeah, it's right here. Did we implement it? Not sure. Yes, we did, but how come we're not? We tried to set it earlier on and we said we didn't have it, so could spell things wrong. Yeah, component velocity, of course. Here, not position. Component velocity set friction. And now we set a high friction, so whenever we press the keys, it shouldn't be. Yeah, I spelled it completely wrong there. Component. Build and run. Here we go. But we're still moving downwards, so kind of weird. Yeah, very weird. Because if we set, okay, we're setting friction to 0 down here, and we want to have the friction to something higher, so that's why it's not working properly. And now if you go down here and you're gonna have a look at what's happening here now, you will notice that our character is now moving as before. Cool. Nice. So we got our character back in game. And of course, assuming it out. We're gonna fix so we can have this character centered on the screen now. That's our next thing. So we need to go into our control. Is it the ISO world or is it the entity? Gonna check my notes here. I think I'm gonna throw it in here just to have some fun. Render ISO world, and we can just say that here, if the ISO engine game mode is equal to game mode object focus. I'm gonna say the control entity is equal to system control entity get control entity. And we've done a little ugly hacking to just have a player there in there for now. If this is being controlled, then we will say that is larger than 0. We will throw in our nice entity position.x equals position components controlled entity.x entity size, but it equals render 2D components control entity dot texture and a quick bracket with. I'm gonna copy that guy and just get him down here. Change these for our nice quick bracket height there instead. And we're gonna say ISO engine center map on the ISO engine, the entity position, and the entity size here. That way we will know how large our entity is. And I think we also have our control ISO world. We have our space bar somewhere as well we need to fix. Just gonna make sure we have that somewhere around here. Yeah, we have our key toggle game mode here. So yeah, we are supposed to toggle that with the component image keywords there. We will toggle the game modes, yeah. So that should be set up for now. Well, we're not registering the spacebar up here, so you didn't have to see that. So I got some small minor errors over here. Yeah, right here. Game mode. That's why it's not working. And build and run. I'll bring the guy down and see if it's working now here. It's not registering our space key. So have we added it to the keys here? No, we have not. So up here we have not added our thing right here that we needed. Oh, I'm gonna close this console down up here and and we need to add the another action. Component keyboard. Component input keyboard. Add action. Input keyboard components, the entity, and we will add our toggle game mode. And we're gonna map it to the SDL scan code spacebar. Okay, are we having better light now? Yes, we are. So I'm gonna pull this down for you. So I press spacebar, we can go around, and if I press spacebar again, we have him centered on screen here. Just as we had him before, so we can press spacebar and get things back up, we can do our tile picking and whatnot. And if we have him centered, we can zoom in and out on his position here. Like so, and you can see here that we are having some nice clipping on the sides here with when we're zooming in. See, all the tiles are not being correctly displayed. We can fix that quickly. Alright, we got our game moves back. So if we head into our entity here, our render ISO world, and here we have to change a couple of things. So I think I wrote this down in my notes. Can I just have a quick check here? Yep, So we should go with -6 here and -20. And since we're doing that, we need to add a few things here. And here we can add in our, instead of putting these guys down here, we can move them up. So you can say that instead of +5 there, we can throw them in here and just say 5+, and this will have to be turned into 8 now, plus the window things. And here we needed 20. This guy is 26, so we can start with that. 26 plus. Alright. Go build and run again. And we throw this guy down. And we zoom in on the player. And we can do... If we zoom in now, we don't have the clipping on the sides anymore. As you see here. Sweet. Cool. So what's left now is actually to write our binary search things and all this cool stuff to sort all the entities that are available on screen. So that's what we're gonna do now. The final thing in this tutorial is taking, I don't know, 15 hours or so to get here. But it's pretty cool. It's my first tutorial series that's this big ever. I've written some small stuff before, but I never recorded at the same time, so it's interesting. Okay. If there are no entities in the array, if entities player but num entities, if that is equal to 0, and if you don't remember what these guys are, we actually set up some entities around here. Entities on the screen is what we have here, and we can go. This is the one we're going to allocate, and we're going to work with rows and the Cartesian positions and so forth. Well, we'll get to it. Entities. We're taking them in here, so we could use it down directly if we want to, but it's okay this way as well. Entities, layer, let num entities, no, entity list 0 equals entity. Did we allocate them? Forgot, because we wrote this a lot earlier on. Yeah, we have allocated them, and we're allocating all the things here. Good. And we can go down and be happy about that. Then we're just going to go and insert the entity on index 0. And we'll increase counter for number of entities in the array. Or in the list, whatever you want to call it. We say that num entities plus plus. Now we're gonna return, because if the list is empty, we just push the thing in there. Here we will get index where the next entity should be inserted. Insert index equals binary search entities layer and the entity here. We'll implement that soon. Then if the insert index is not equals to -1, then we will say that we check if it's the first index. We're gonna move everything one step forward and the entities, right? Move. entities, we will get the layer, and this list plus 1, and we will get the entities layer dot entity list plus the insert index plus 1, and it's going to be size of struct entities on screen multiplied by, and it should be the layer. It's going to be a long line, so we can go and say do like this: multiply by entities layer dot num entities plus 1, because we're moving everything forward now in the array. And if you don't know how memmove works, then you can go and look it up on the internet a little bit more, because it takes some time to describe everything. But we'll go move everything from the insert index forward. So we're gonna do here, we're gonna move entities on the layer they are on, and the list plus the insert index to and forward entities layer entity list plus insert index minus 1 on this side. Here we're gonna go size of entities on screen post. I think I got something wrong here as well. On the other line here should be entities entity on screen post T here. That's the one we want. Same guy here, and we're gonna multiply that with entities on screen. Would be the layer but num entities, and we also have to add in a plus 1 here, so we will copy everything forward. So basically what we are doing, if we bring up Krita, I'll give you a quick explanation what's happening here. And these guys here with the memmoves. Here comes Krita. So perhaps I should do something like this today. Put it on half of the screen here. New texture. That's cool. So if you check on this first memmove, so what we want to do with this one, if it's the first index, so you have the array here, and here we have, say we have, for simplicity, we have 3 values, and so you just call them 0, 1, and 2, or we can call them 1, 1, 2, and we get a new thing. We want to insert a 0 into this one. This is a sorted array already, because what we are building is a sorted array from the beginning. We have an empty array first with nothing in it. So if we have the empty array, you can go down here, empty array here, then we insert a 1 to the array, and then this becomes a 1. You have 1 element here. The next time we want to insert a 0, we're inserting it to be sorted. So we find the position for this, for it inserted, and we know that 0 becomes before 1, so the array will be 0 and 1. Like so. And in the case with the first memmove, we have already inserted a lot of things. So what we're gonna do, we're gonna take this whole array and we're gonna move it forward like this to this position here. So you have your 1, 1, 2 in the array already, and you're inserting this 0 here in the beginning of the whole thing. So we are actually moving this part of memory forward to the second position. So it goes from this position to this position here. And in the second case, we already have an array. Like 1, 2, 2, and 4. We want to insert a 3. So in the second case, we will insert our 3 right after. 2, 2, and here comes our insert here. Our 3 that we want to insert. like that. And here comes our number 4. So in this case, what we are doing, we're just taking the 4. From here, we are moving it here to this position to make room for number 3 to be inserted here. And put the 4th in there. So we're just copying this position up here, and then we are overwriting this position here with a 3. So that's what we are doing with this memo function. So that's a quick explanation of what's going on here. And let's see here. And after we have moved everything, we're gonna write entity at the index, at the insert index in the array. Entities layer entities list, and we're gonna take the insert index, and we're gonna make sure we get the entity there. Cool, and then we have increase entities layer dot num entities plus plus. Okay, and now we're gonna write the binary insertion sort thing here. So we need to define that we have the int first element. It's gonna be 0. Gonna initialize the first element, first index rather, to 0. Int last. It's gonna be entities layer, the current layer we're working with, and num entities and -1. It's gonna be the last index here. Index say initialize last index, and then we're gonna have our in search what we're looking for, and the first and lost divided by 2. So in the beginning of the first videos, I know in the one of the beginnings here of this series here in part 3, I was describing how this thing worked, and initialize the first search position to the middle of the list, or the array / list. Okay, as long as the first index is less or equal to the entity, sorry, less or equal to the last, of course, while first is less or equal to then last, then we check if we have found position to insert the entity into. This is going to be a long if, so we're going to do like this. I'm going to say the search index Cartesian y position is identical to the entity Cartesian, and of course search search, and it should be a big C, because I don't know why they want them to be a big C. Don't ask me why this word spelling thing want that. I don't care, as long as we get rid of those ugly red things. Entity list search. So what we are going to do now is we are going to compare if the Cartesian y position is less or equal to the position. So let's bring Creed up here again and just quickly explain what's going to happen now. So what we're doing now is we have our map here, and on this map we have some objects. Say we have a box there, we have your circle here and a triangle here. So what we're doing, we're checking if this is the y position, the Cartesian y position on the screen. Here you have the screen, and in this direction you have the y, in this direction you have your x. So we're checking if we're getting this y position of all the objects here. This is the object plus its offset. So basically, we're checking the base of all the objects. So you can even check, well, it's the base we want to check to see if it's less or equal to this one. So in this way, we will sort all these objects into our array. So if we start with the first one, yeah, here. So this one has entity index 1, and this one has 2, and this has a 3. So we go here. Here we have our array. We're inserting the circle first. Then we come into a second object. It goes in here. And then our third object comes. Then the list will change and become 0. Sorry, the circle, and then the triangle, because its y position is lower than the triangle. So we're inserting the object here, and it finally comes to triangle. So we're doing an insertion sort now with binary search, so which is very quick. And of course, we make the recap on binary search. So we have an array here with our box, our circle, and we have a triangle. And a triangle, and a triangle, and a triangle, and whatever. So this should be numbers. It's easier in that way. But if you want to insert, I can take another one here. We have the middle of the array, which is going to be around here. So what we do is we want to insert a square here. What happens is that we check here first in our array here objects. Here we get the middle. And then once we have the middle, we're checking is this has obviously a value. This is lower, this is low, and this is high. So what we're doing here is we're taking the middle position here, and we're checking is this object, is it low or high? Higher than with the position we have, because this is sorted. The array is always sorted from low to high. So then we know, okay, it's lower than. So what you do then is say that this is going to be the last position now. Here, we're setting the marker that this is going to be the last position, which means that even if you had 9,000 of these guys over here, you're skipping these guys. You know you're going to find the next position. So the array is now looking like this. The square, the circle, a triangle, and a triangle. So what happens now is you have the beginning here. This is still low. So what happens now, we're taking the middle again. So we're standing here. So we're checking, is the triangle, is this lower or higher than this position here? Well, it's lower. So then we got two values left here. You got a circle. Now this here is lost. And this is the first, this is, of course. F as in fast. So now you're standing in this object. Then we can just check if this one is it lower or higher? It's lower. So then you come down here, you know, you can just insert it because you found one object left. So you can, it doesn't matter if you insert it here or here, because they are the same in this one, in this case. So the array will become like this. You insert the object here in the array, and then all the rest of the items comes. So easier to do like this. So that's the final array is going to be like that. So you insert, it could be on this position or on the first position because they were equal. So that's how binary search works. You find the position you want to insert your object into, and even if it's super large, you just, as you can see, you're always jumping. So you start here in the beginning, then you're jumping to half, and then you're jumping to half of that. So in just 2 steps, and the compare, I can insert this square here. So of course, if I was doing a search from the beginning, you know, with a simple compare, that would compare every single value, we would find it immediately. But what if we wanted to insert, say we have a new object that is like a strange 5. Well, whatever, a diamond. And diamond has its position over here. So if we would go through the area like this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and this had the position like 1000. We would do 1000 compares before we find the insertion of the object. And that's a very long time, so it's better to do a binary search to find the insertion point. So I didn't mean to do that, what I just did to describe this, but hey, better to be clear than not. Okay, so get back here, entity. entity, and we're checking if the Cartesian position is the same, or if the search index Cartesian y position is less than the entity. Here we go, entities, layer. We can just copy that because it's what we're gonna be playing around with anyway. Copy that because we're gonna have a lot of those guys. Into layer dot num entities. I'm gonna make sure that there are more than one in this case. And into this layer dot entities list. Search Cartesian y position. This will be less than the entities, and the entity Cartesian y position. And the entities layer dot entity list search. We're going to check one forward as well. Cartesian y position is larger than entity Cartesian position. Let me think here, how many parentheses do we have? We have one, and this one is ending here, so that's good. We're including these two guys in the same thing here. Or if the search index is less than the number, not the number, then the Cartesian y position, and the search index is. It's a bit hard to describe it, but Cartesian y and the search index is larger than the Cartesian y position. The search index is less, and the search index is larger. Yeah. Can copy something, I guess. The whole thing. See what we can do about this. Now maybe this is start larger than that, and the search is larger than 0. We make sure that we are higher than the first position there. And entities layer search -1. Cartesian y position is less than entities Cartesian position, and the entities layer entity list search dot. Just a search here. And the Cartesian is larger than entity. Good. Or if the search point has reached first or the last index in entities. First, or if search is lost. Okay, that's a long one, but sometimes you got to do some nifty checks. So this took some time for me to get right when I was writing it. So let's see here, if the search index Cartesian y position is less than the entity Cartesian y position, entities layer entity list search for Cartesian position is less than entity Cartesian position, and we have to make have a special case here. Case for when the first and the last position are next to one another. I counts my daughter with the game and she's playing around with it. So that's what you're hearing. This wee weenie. I think she's playing Pooh, P-O-U on the mobile phone, whatever. Special case. Okay, if first plus 1 is the same as the last, then we check if the last index Cartesian y position is lower than the entity Cartesian y position. Entities, layer, entity list, search plus 1, the Cartesian position is less than the entity. Doesn't matter, you don't have to say equal to, because if they're equal to, they have the same position on y, so we don't have to check that. So if so, the index to insert the entity into is at the end. Okay, that means we return the search plus 2. Whew, lots of stuff. And down here we would go else. Here we would return the search index plus 1. Search plus 1, and here we just else. If not, then we will return the search index. And go return search. Maybe that one, and else if the entity Cartesian y position is less than the requested entity Cartesian y position, layer dot entity list search the Cartesian y position is less than the entity Cartesian position. Set the first index to the search position plus 1. Otherwise we will otherwise if the search number or whatever the search y position larger than the requested one, set what am I thinking wrong here? Else if there we go. Otherwise we have else. That's what I'm looking for. Else set the last position to the search -1. Search -1, and then we move search position. Search equals first plus last divided by 2. And return -1 if nothing if it was not found. Position was not found. Return -1. Okay. Whew, that's a long function to write. How many errors do we have after that typing? So should be ending here. Function expected expression before. That's kind of cool. And do we have them all? Yes. That one is there. This one is there. This is the things that I hate when I'm getting blind of my code and not seeing what the error is. So that one is correct. Is one of these guys wrong? So you just comment them out and see if it's building to know which line we're. It's still expecting something here. Then what did I do wrong? Or is it that we can't have the size off on the same row like that? Don't think so, but should be working. Build. Man, why am I blind? So that was clearly not the problem. So move entities, comma, size T. Well, I'll be having a break because I'm blind right now, so. Okay, it was very simple. There was a big minus there in the beginning of the screen, so that was the problem. So do like this. Build. Expected before equals, of course. And go build, and there we go. So I'll be having a final break before I will write the last things of this tutorial. And the best is yet to come, as they say. Alrighty, let's see if we can get this final thing down. We have just added our stuff. And unused variable because to build here it's cute. Okay, this is what we have. This is what you saw the last time. So let's see here what we need to do. We got the binary search in there. Insertion on screen entities. So we got to update our little thing in here. The system render isometric world stuff here is in need of an update. So I'm gonna make sure we get my notes set up here as well. Oh, wait. We got one thing here. A big thing left. Here we have it. System run isometric world sort entity. This is where all the fun stuff happens. So, I'm gonna point. And we're gonna have let's get 10 point. Entity on screen. Pause T. New entity. Gonna have thing to play with. I'm gonna also have a reallocation of the whole list. New entity list equals null. Human 32. I just for looping stuff. Int layer equals render 2D components entity, of course, and its layer. And we have to make sure if the system failed to initialize, then we will, as usually, just say return function, like so. Return if it's the first entity. No. If the, that's for later. If the system has failed to initialize. Here's where I want it. If entity equals 0, then we reset. Because every time we are looping through, let's see here, we're gonna go to the systems here. EZS and system, and we go into scene here. Let's find our run loop somewhere around here. Yeah, up the system scene. So you see here we are looping through all the entities. First entity to all the entities. So So each time when this loop is done, we come to the first entity again. So this is where this stuff is happening. Let's get back here. So each time we come to the first entity, we will reset our list. Reset entity list. For you gotta do unit 32 cost here. ISO engine, ISO map, num layers, like so. Num entities, draw last frame equals 0. It's gonna keep track of that. And we will also have entities on screen. And we're gonna get the I. I'm gonna set num entities equals to 0. Cool. And we will also do a here. The current entity to draw is 0. So this guy here is that we will iterate the list from the top to the bottom, because on the top we're gonna have the highest, the first entity we have to draw based on its row on the map. So that was that. And if the entity has a position and a render to the component, entities, entity dot component set 1. If it has the system render ISO mask set 1. So if we got the mask for the system here, this guy here, that means it's position and the render component. Then we will get the object position in the world, point.x equals, and here we have, do we have post components? Yes, we do. Entity dot x multiplied by the ISO engine, zoom level plus the ISO engine, scroll x or the camera x position, and we change these guys to y, scroll y. Cool. Now we'll convert position to isometric coordinates. Convert 2D to ISO, when we convert to point isometric. Now we'll adjust the position to isometric. Okay, that's what we did. Adjust the position with its offset. Position with its offset. So we have point.x plus equals the position components and the entity and the x offset multiplied by the ISO engine dot zoom level, or not dot, but the pointer to it. And this goes with the y, like so, and here we have the y offset. Cool. And if the entity or the object is within the screen area, point.x plus render 2D components, entity dot texture and its width. Here we got multiply with the ISO engine zoom level as well. If that is larger than 0. And the point.x is less than the window width. Like so. And we can copy these two lines because we need to enter the same stuff basically, and that the point dot y plus run and the width, sorry, the height here, blah blah blah, and the zoom level, and then here we have window height instead. Then we know it's within the screen area, and here we will have step 1. Here we will store the entity height, and we will get the position of the entity. TMP point dot x equals pass components entity, and it's x multiplied by the ISO engine zoom level. And we get the y point as well. Here we convert the point so we can track its height in the isometric world. ISO engine convert ISO point to 2D Cartesian. ISO engine, we get the TMP point here. And we're also gonna get the 10 point here. Like so. Now we store the entity y position, which is its height on screen basically. New entity, the Cartesian y position equals TMP point y. We have step 2, which is to store the entity tile height. So we start with get the tile position for the entity, which is going to be 10 point dot y equals pass component entity dot y divided by the ISO engine ISO map, and a tile size, we multiply that with 0 by 5, which is the same as the 0.5 is the same as divided by 2. Now I don't know about the compiler, what it's gonna do, if it's gonna optimize or not, but we'll do for like this for now. So you can write divided by 2 if you want as well. I'm gonna get the x. It's gonna be the same, and then we will convert the point so we can track its row in the isometric world. ISO engine convert will convert ISO point 2D point 2D to Cartesian. That's what I was looking for. ISO engine see here, it should be the same thing as above here, yeah. Good, now we converted that, and then we will do, we're going to store the row for the entity and make sure to multiply with the zoom level. It will work, and the game is zoomed into new entity dot row equals, we will convert this an int tv point dot y. We don't care about the x point, but in order to get this function here to correctly translate our point, we have to have the x position as well in the 10 point here. So that's why we are calculating the x as well, because this function needs it to in order to get the right y position. Isometric with a zoom, Isometric zoom level as well. Step 3, we will store the entity ID. Now what's going on here? New entity dot, thank you, entity ID is equals the entity here. Good. Now step 4 will be allocate more memory if needed. Now when I was doing this earlier on, when I was trying these things out, I realized that we were, because of a function down here, that we are moving memory forward here with the mem move. We're gonna write over memory. If it's not allocated, then we're gonna mess things up. So I was trying to find a good way to solve that, and the best way I could do it was actually just to make sure we never write outside of the allocated memory. We add another 1000 entities whenever the number of entities half of the max entities. So we're gonna waste a little bit of memory here because I didn't find the exact value that it was supposed to have. But move inside of insertion sort on screen entities is moving entities forward in memory. Now we're going to see here if entities on screen layer dot num entities, if that is larger or equal to entities on screen. It's not going well with my typing today. Entity, sorry, not entity, layer, of course. Layer dot max entities. And we're going to divide that by 2. Then entities on screen. Layer dot max entities. Going to add another 1000 entities here. Try to allocate another 1000 entities. New enter the list here is going to be equal to realloc. We're going to get entities on screen. We're going to take the layer entity list. And we're going to say size of struct entity list on entity position T is the one we want. I'm going to multiply this with entities on screen. Layer dot max entities, of course. And if the new entity list is null, if memory allocation failed, okay, first I have to roll back the entities. Roll back the entities that we tried to add. So we're just going to copy this guy here. Say minus equals to 1000, and we're going to do a log the error here if we want to. And we can just do I'm not going to do it, but it's going to go, or why not? Write to log error in function. The thing is, every time this just trying to reallocate, it's going to write a lot of stuff in here, so. But it's better to write a million errors than to write none and not know what's going on. Could not allocate. Reallocate memory for entity depth sort of thing. That's basically what it's all about. I'm gonna write this to unlog.txt like so, and return out all the function like so. Here we go. Else if memory allocation was successful, then we point entity list to the new memory. Entities on screen layer entity list equals new entity list. And initialize entities. Before I equals entities on screen, and we're gonna say entity layer dot non-entities. We start there, and then we allocate all these other guys here. I up to entities on screen layer dot max entities. So we'll allocate all the new ones that we have not added yet. And we can copy this guy here. Just gonna do some initializing here. Dot entity list I. Copy that stuff, and we go Cartesian y position equals 0, and the entity ID is going to be 0, and the row is going to be -1. And now step 5. Is to perform the binary insert sort for the entity to the entities list or area, whatever you want to call it. I'm gonna say if render to the component. We can actually do layer if layer is larger or equal than 0, because we're only passing the stuff in. You can say that insertion sort and screen insertion sort on screen entities. On screen, and then we're gonna get the layer, and we need the new entity here. So we're gonna add it to a list, and that's all the steps, like so. And how many areas do I have now when I build this stuff? Binary have in other branch the binary have struct isotile in double. Some point x equals the position entity that why is this not working, man? It's usually have struct isotile set and double. Is this one pass components? Is this the position components are also already floats, so it shouldn't be that. So I'm having one of my brain freeze again. Not nice. So I'll be taking a quick break, so you don't have to watch me debug and think all this stuff over. And of course, it's easy to find what you're doing wrong. Sometimes it's not the tile set, because we want the tile size, of course. Here we go. Build. Cool. Now let's get back to this function here and see what we are missing. System render isometric world. So I see if I'm missing something here that I need to add, and I'll be checking this guy up here in the Isometric init. So the init function here. Init function, are we checking the Isometric map stuff? Not sure if we are, but we can just leave it for now. Okay, here we're gonna add that the current row. Initialize the current row. Row being drawn on the map. So it's gonna be current row dot y, current row dot x equals 0. So it's gonna see if this is building properly now. Yeah, it is. Gonna make sure that it's running as well. So I'm gonna show you guys what the things that are going on actually when we are drawing the map. So for this, we are gonna go down and have a look here. Indent that. Okay, so what we will do here is we're just gonna grab the render present thing here, and for every tile that we are drawing, we're gonna say render present. And we're gonna do an SDL delay of say delay 10 milliseconds there. Build and run. It's gonna show you what it looks like when the stuff is being drawn actually. Not responding now. That's nice. It didn't like me doing that. Okay, well, debug. Build the board. So how do I get that stuff down here? Well, we can add a delay in the beginning for like 5 seconds so I can pull that thing down for you. Let's go to here and we add a delay when the init thing here. Here we go, SDL, delay, like 3 seconds should be enough to get the thing down here before it starts doing all this stuff. Yeah, okay, you can see it now. Cool, that's what's happening. You can see how each tile is being drawn, so it had a hiccup there, you see? It's drawing each row. It's a bit too... trying to press the escape key here. There, finally managed to get it down here. So we will add a, we don't need that probably, and we're gonna go down to our render Iso world, and we're gonna add a delay of 100 instead, so you see all the tiles being drawn, tile by tile here. If I can get this guy down, it's gonna be not responding for a while, but it's gonna get back here as soon as it has done its first draw call. Which is going to be a while, because it's not responding because I was doing that. Well, we can wait a bit for it. Hopefully. It doesn't like when you're dragging the window around, when you're doing a lot of SDL delays. But meanwhile, we can wait for that to start drawing. So I'll be checking back on that in between. So what we can do is continue typing our code here. We're gonna add the thing here, which is gonna be called float num tiles in. No, sorry, zoom. We have that one right here, so zoom level tile size calculate. It's not drawing yet, so we'll wait for it. If it starts up, I don't know. And we can do Iso engine, zoom level, Iso engine, isomap tile size. Like so. Next up, we are doing our things here, and we're getting a tile from map down here. We can do like this, can put this guy up above here, and we can go here and say get the y point dot x gonna be equals to x multiplied by zoom level size pre-calculate, and point dot y is going to be equals to y multiply the zoom level size pre-calculate here, and fetch those, and we're going to get, see if this is drawing or if it's just, okay, the window is not even displaying now. Well, that didn't work as we planned, so I'm gonna do that delay in the beginning because I want to show you what's going on, because it's important, at least to me. And let's do an SDL delay in the init function here. For 5,000, like so. 5 seconds, and that should be good enough of time for me to get this sucker down here. At least I was hoping so, but I can't even. Okay, that's the wrong one. It's another thing. Here we go, build and run. That was the end result which you wanted to see later on. And what's going on now? Build point dot y. Well, build and run. It's not delaying for 5 seconds. And my mouse is actually locked in the window now. Buggy stuff. So I gotta have a quick. Okay, close the program. I got out of that thing. So in here is where actually we're gonna add that SDL delay here. Delay, and we're gonna have a 5,000 delay before we start the program. Actually, even before here. Right down there. Build and run. I'm gonna get the window down if I can. That's kind of buggy. I can't even get the window down. That's SDL for you. Okay, here it comes. Okay, and you can see that it's drawing row by row here. That's what I wanted to show you, that every row we're drawing is actually one row, row by row. And now my mouse is locked in the window, so you can do Alt F4. Should actually just remove that code, and that will be easier to fix things here. Not responding, that's what I want to have as well. There, close the program. Thank you. It doesn't like that delay. Or rather, it doesn't like that I've locked the mouse inside of the window. So, I've shown you what I wanted to show you, and we can go and remove those two lines. Render present, and that's delay, and we can continue here. Draw entities here, and we're gonna get the tile, and we're doing that up here. Here. Get current row. We are drawing on. ISO engine convert ISO point 2D. And with the ISO engine, ISO map X and Y and the layer, like so. I'm gonna check if the old row y is not equals to int the current row dot y. We'll update. Okay, if the map is drawing on a new row, we say update the old row value with the new. Old row y equals int current row dot y. And if there are entities to draw on this layer, layer dot num entities is larger than 0. There is as long as there are entities to draw on this row, while entities on screen, layer entity list, and entities on screen, layer dot num entities. No, sorry, current entity to draw dot row. Gotta get the row. Oh, it's a long line. If this is equal to int current row dot y, and here we gotta do a special little thing here, which will be ice divided by the ice engine isomap. Come on, give me a break. Isomap and the tile size divided by 2. Cool. As long as the row, if the entity is standing on this row, then we will have to we will draw it. Here we go. We render the entity. System render isometric object. We have the entities on screen, and we have the layer and the entity list. Entities on screen, and we need the layer for that. Layer dot current entities to draw, and we have the entity ID here. This is the ID we're basically used to draw the thing here, the object. To the next entity and the sorted list. Entities on screen, layer dot current entity to draw. You can increase that. And here we will update number of entities drawn last frame. Num entities drawn last frame plus plus. Good. And where does this go? It goes there to this stuff there. Good. And we can go down here. And there shouldn't be anything else, I think, other than this. And we probably have some errors as usual. Argument 1 of that stuff. Is it really this we are doing? Drawing to this here. Oh, I think it should just be get the camera drawing on. It shouldn't be like this. It should be ice engine, and we need the point and the current row, like so. That's what we need. Good. And build and run is probably gonna mess things up and not work as usual. Nope. Or is it? It's actually working. Cool, I'm gonna bring this down for you. So we are drawing here on the screen. But of course that mouse is always, it's locked inside the window, so it's having, can just center on a guy now. Cool, so we're gonna remove the code here for drawing this guy here. Here, remove, this is the line that we were using before. It's gonna allocate some memory now. And see if it starts up. But we're not seeing our guy here, so I'm gonna make, okay, we can't see anything here yet. We can move around, but we don't, he has a position, but we can't see him. We're just moving him around, so I'm gonna find out why. So I'll be having a quick break to solve that little problem. Be back real soon. Okay guys, I think I found one of the errors is here, and it should be layer instead of 0 here. And I think we have not added it in the scene here either. Yeah, here we don't have the system render sort entity function is the one we want to run all the time. And also, if I do not mistaken, you can go back here and check that we have everything in line here. Here, XX. Oh, should be Y here as well. Now, and build and run. It's allocating some memory now. Don't know how much, but I'm gonna pull the guy down here. So now we are drawing our character here, and if you see, you can pan to the sides here, and it's being drawn. So why don't we add some nice tiles to our second layer now in our Isom engines thing here. Isomap, generate Isomap, wherever that guy is. Here we have him. Awesome. So let's see, Isomap, what we should do around here. So first of all, we want to know if it's null. Should add this in here. Write to log. Error in function. Iso map load tile set. And we'll say that the parameter isomap t is null. We'll log that to the run log, and we do a return -1 here. Cool. I want to make sure we're gonna change this whole function here. Not this one, but the generate function here. Not a lot of things will change, but a little bit. Here we're gonna say that for. Just copy these guys here. And do like that. Height, I can go rand if rand percent 100. Modulus of 100 is larger than 90. So 10% chance, then we just control isomap. Set tile, and we put the tile on the isomap, of course. And X and Y. I go see here, layer 1 and value, say 0, 1, yeah, 2 in the file. So I can bring it up for you perhaps here. And let's see. Just gonna make sure to double check that we get the right image. Our second layer. Data. I'll open this with photo viewer. Yeah, 0, 1, 2. We're gonna have this block here to be painted on the second layer. So that's true. And what we can do is we can set up some blocks as well. Isomap Set tile, we can set it on the isomap, of course. Why don't we just copy this guy? And we don't have to think too much about it. And we can go X and Y. I can go 0, 3. I go 1, 2, 3, 4, 5. And then we changed our map and go build and run. Okay, we have our 5-second delay during the start, if I don't remember wrong. But now we're gonna do some fun stuff. So here comes our character, and I'm not sure that everything is good with this guy. But here, see his clipping. We are now walking around on our map, sorting everything in real time. See there? There's his feet, and here it comes. Yay! Cool. So why don't we throw in some other stuff here? And I showed you the wrong version, which actually the built version. I executed the wrong one, so the one I've been working on earlier. But what we're gonna do now, we're gonna copy a file. I'm gonna show it to you first. Let's see where I am. Where I am at. Obviously the wrong folder. But soon we're gonna get the data. Here we go. Open with Windows Photo Viewer. Here we have a nice little tree that I drew earlier on. So I'm gonna throw this guy in here. So I'm gonna copy and put him in the data folder. So you can see what I'm doing here. I'm gonna click myself over there now to the tutorial series part 3 data. And in here we're gonna paste my tree, ISO tree. So we should add this guy now to our stuff. In the ISO tutorial we can go up here, and this has been a long session, man. I don't know, I've been working like 16, 17 hours on this guy now, on this tutorial, and it's fun. It's a lot of fun, but it's a lot of work. So here we're gonna add data, and we're gonna add a tree here. ISO tree.png. All low caps, so that's nice. Pretty good. And now we're gonna add some code to draw a lot of trees on the screen. So I'm gonna see here what we should do. We can go into our and of course we gotta remove our delayed here for the 5-second stuff that we don't want to have. That's just in our way. And we're gonna go down here and we're gonna say here. Add tons of trees to the map. And a smiley, because we like that. For I equals 0, I up to 10,000 of those, plus us I, and we can go and can add a tree entity to the scene. I can go entity, I can go ECS scene, add entity to scene, and we add it to test scene, and he's gonna have some flags on him. Start behind here, back here, component. Set one position is a good thing to have. Set one, we can start with the position, and we can add another name tag on this guy. And he's gonna have a render 2D. And how about a component? Set one velocity as well. And of course, we need to wow, where's my caps coming from? Caps lock, of course. every time we add a new. Well, we can just copy this guy up here and save you a few seconds of watching me typing. And we can give the tree a name. Tree presentee. That's what we're gonna give him. Simple name is a component name tag set name. Name tag components, and on the entity and MSG here. Cool. I'm gonna set the tree start position, component position, set position, like so. We can do position components, and we can say entity. I'm gonna randomize 400 by 400 on the screen so we can see everything. Modulus 400, and copy that actually. Like so. And then we have set that stuff, and we move the tree offset Y position up a bit. Component position set offset. The position components, and we're gonna add the entity. I'm gonna add 0 to the X position, but we're gonna move the tree up with 96 here. Like so. We can set the texture to render. Component render 2D. Texture add clip rect. Good. Render component, render 2D components, and we're gonna add the entity. The texture pool. Pool get texture from texture pool. In the game.texture pool, and we're gonna add the ISO tree. PNG. We're gonna pass in null on the clip rect because we just want to use the whole image. Now, you want to set the friction to 0 as well here. Component velocity. Set friction. And the entity, we're gonna set it to 0, basically. And as a final thing, we need those as a set which layer to draw them on. Component render to the set layer. We're gonna set render components. I'm gonna say the entity, and it's gonna be on layer 1 because that's where we are drawing all the other stuff. So how about this? How about drawing 10,000 of these guys? I don't have an int. Well, let's get an int then. Int I is 0. Expected identifier. Well, you want to have a semicolon. Build. Too few arguments components at friction. Yeah, because we need the velocity components. Build. Okay, okay, I'm having a clipping error here with the trees, so we're gonna find out what that is all about. So I'll be back real soon. You didn't see that. I can show it to you that we are not doing properly here. Let's get things down. See, the trees are popping up and out here on the screen. So if I move down, we're not drawing everything. So I gotta make sure I find that little bug and be back. We're in the end of things, but I'm gonna find this one quick and be right back. Okay guys, so the final things are, we have forgotten to return here out of the function, and we are doing an extra thing here on the insert index that we did not need there, so that's why. And we go build and run. And let's see what we get up here. I'm gonna pull this down for you guys so you can see. Here's our nice forest zoomed out and ready. And we can also get our other stuff up here. So here we are. And we are drawing 18 FPS right now. It's because I'm screen recording, doing things at the same time. And we have our character here. So that's a nice test we can do to see how much we can draw on the screen. That we have a 19 FPS there, 18, 19 FPS, drawing 10,000 trees on the screen at the same time, and that's kind of cool. And we should get our stuff to draw a little bit less trees. Here, so how about we draw like 200 trees all over the map, and the map we can just add around 2000. I think it's 2032 if I don't remember right. Remember wrong, rather. So let's go and build and run. Gonna pull the stuff down here. Currently we have 3000 FPS, and the trees are of course draw random on the screen here. So we're going back. And so we're clipping here with the trees. Then we're running at 1300 FPS per second here. So we can walk around in the forest now. Nice. Oh, and tile picking is not going to work on the top layer because it's only picking the tiles on the first layer. So that's something for later to fix. So if I click on this stone block, it's going to get the tile beneath it. So, but you can see here it's working. And I gotta figure out why the game is starting in a zoomed in state, so I'm gonna look at that as well to see where that is being set and throw up the tutorial for you guys. So it's been a long, I don't know, 16 hours or something that I've been recording and making this tutorial, and finally I am done. I'm gonna look at that memory bug as well, so I think I'm gonna release a cleaner version than what I've been coding here live for you guys. Something that has been memory tested and everything. And I should do a tutorial with Valgrind, or it's actually called Valgrind. It's the correct word in Linux, to show you guys how to do that. If we zoom in, we are having 3500 FPS. All the way now. Is it 1000? That's nice. Well, it's more than enough FPS to play around with. So, and even if we draw 10,000 trees on the screen, we still had 19 FPS, and I have like an old graphics card and screen recording at the same time, and well, it's okay, guys. This is the result we wanted. We got some clipping here, and next tutorial should be adding some collision detection for these guys as well. So we have collision detection between entities themselves. Oh, let's do this. This is fun. Let's add one more thing before we close up. It should be just about one line of code. Yeah, let's type it in here somewhere. Here you can set component velocity. Set velocity. We can just say velocity components entity, and we can say about 10 plus random percent. About 100, and 10 plus random percent 100. This is the fun thing when you're doing these kind of things, that you have a lot of entity component systems are really nice because they let you move your trees around. So here we are moving trees around at the same time. Let's get our FPS here. 1000. Yeah, and they're off the map. how about we add a few more trees and have some fun with that quickly here before we go. Let's say we got 2,000 trees on the screen, and build and run. Move this guy down here. Bit too much down. And let's go bring the console here. So here everything is being sorted in real time. We have 800 FPS here drawing, I don't know. Oh, we forgot to add that one. It's one line of code actually. So this is where the fun stuff is. Render. And it's actually the are we printing that? I'm gonna have a look in my code quickly. To remember where we are drawing, where we are putting that on the screen. Yeah, here we are. Should just do it here in the end of here. It's a good place. And we can say that we drew %d entities lost frame, and this will be num entities drawn lost frame. Cool. And then we can go build and run again. Get that stuff down. This guy as well. Just do like this and move around a bit quicker. Drew 200 entities, and here we have like 300 entities, and still at 11. See here, the trees are all flying around. It's still having 1500 at 1600 FPS. And when we're drawing the map, it gets a bit slower because we are drawing all the tiles as well for 2 layers, which is nice. So it's down there, you can see the trees coming, and we're clipping. Sorting on the Y position. Alright guys, so I'll be calling this finished tutorial, and I gotta have some check some memory bugs and stuff before I actually release this out into the wild. So I'm gonna be running the code in Linux with Valgrind to see that things are working. So thank you for bearing with me with a super long tutorial about how to set up entity component system and all these crazy cool things. So I'll hopefully be, well, I'm gonna take a break now, a month or so, to recharge my batteries and then work on the tutorial part number 4. So thank you guys, and hope to see you in the next tutorial. Bye for now.